Hey everyone, it's Dr. Walker. This is video 104C on circular satellite orbits. This video is really a continuation of the Kepler's third law that we just saw in the previous video. If we're looking at circular satellite orbits, then to figure out how fast these satellites are going, now note, what is a satellite? A satellite is any mass that is orbiting an object as long as the mass is much smaller than the object being orbited. So it doesn't have to be, a satellite doesn't have to be like a spacecraft around a planet. It can be a planet around a star. So if we're trying to find the speed of that satellite, we can just use Newton's second law like we just did for Kepler's third law. We said that the gravitational force on the satellite is what provided the centripetal force. From this equation, we know that the mass of the planet, or whatever the satellite is that is orbiting, cancels out, and then one of the radius cancels out here. So if we solve for v, we just take the square root of both sides, we get square root of gm over r. So m is the object that is being orbited, and r is the distance from the center of that object to where the satellite is. So this is not really a new equation, but it does give us a convenient form of the equation to find v. Now, if we are orbiting at any height above a surface, then the distance r is going to be the radius of our big object that's being orbited, right, plus the height. So that's what we're going to plug in for r. So we can find the speed of a satellite. We can also find the period of a satellite. And this is just Kepler's third law, where we have solved for t. So we remember that Kepler's third law had t squared and then r cubed, right? So we've just taken the square root of each side to find an expression for the period of the orbit, or how long it takes to go around the object. Let's look at one question. A satellite originally moves in a circular orbit of radius r around Earth. Suppose it is moved into a circular orbit of radius 4r. Then what happens to the speed of the satellite? Go ahead and try to do it on your own. You know, I like this type of question where we change one variable, we want to know what happens to another. The first step is always to write down the relevant equation. In this case, the speed of the satellite is given by the square root of gm over r. And now the radius has become 4r. And so we can use big R because it's using big R for the radius. And now we're going to change that to 4r. So the square root of gm over 4r. Well, what happens when we take the square root of 4? We get a factor of 1/2 here, since 4 wasn't the denominator. So we get 1/2 times gm over r. So the speed becomes half as large when the satellite is moved into an orbit that has 4 times the radius.